There are 2 pointers, one on the left, one on the right. They start at both ends of an array and they move towards each other. At some point they meet. This pattern is called the 2 pointers pattern, and we can use this pattern to solve quite a few LeetCode questions. In this video, we will talk about what 2-point patterns are and then how we use them, and we will develop a template so that we can apply that to specific questions. At the end of this video, we will also apply that template to a specific LeetCode question so that you can see it in action. So let's get started. Let's first talk about the main idea behind the 2 pointers pattern. There are 2 indexes, one on the left, one on the right, that scan the array. And we move 1 pointer each step. And the movement shrinks the search space quite significantly. And we never move backwards. We do some sort of comparison, and then that comparison will determine the movement. And then this whole thing will turn the ON2 complexity into an ON complexity. Now let's quickly talk about when to use this 2 pointers pattern. We use it when array or string is sorted or can be sorted. And then the goal depends on the 2 ends. It could be the question stem will tell you if it's a pair or area or condition, and then this goal depends on the 2 ends of the array. So comparison, we do some sort of comparison based on these areas or conditions, will tell us which pointer is safe to move. Sometimes we move the left pointer and sometimes we move the right pointer. And then this movement rule is clear based on deterministic based on the question itself. And then the pointers will meet at some point to finish this whole process. Now let's develop a template code so that we can use in different problems. Step 1 is to initialize pointers. We will initialize a left pointer, which is pointing at the 0th index. And then we initialize another pointer on the right side, which is the right index. And that's the last element's index, which is the length of the entire array minus 1. So this is the last index. And then step 2 is we explore until pointers meet. So the left pointer will meet the right pointer at some point. We do that using the while loop. So left pointer less than right pointer. While that's true, we are going to compute some sort of window from both ends. So this window value, this is the condition, will depend on the 2 ends of this array. So the left value and then the right value, and we will do some sort of function. So this function could be summing it or adding it, multiplying it, finding some sort of area, and we will find that number or our answer. And then after that, we're going to update the answer because we're looping this left and then right. At some point, we will find a specific answer that satisfies our condition. And then if during that process, we're going to update that answer by comparing our answer to that window. And then in the end, we are going to apply the movement rule. For example, if the movement rule says if it's less than whatever is specified in the question, we're going to move the left pointer, else we're going to move the right pointer to reduce the search space. At the end, we're going to return our final answer. So that's our quick template code for the 2 pointers problem. Now let's see how we can apply this template to a specific LeetCode problem. So we will solve LeetCode problem 167, 2 sums 2. The input array is sorted. It will tell you it's sorted. So the question stem is given a 1-indexed array numbers that is already sorted in non-decreasing order, and we will find 2 numbers such that they add up to a specific target number. For example, we're given numbers array, and we will given a target, and then we need to find that the 2 numbers who add up to the target number. For example, in this numbers array, we're given 2, 7, 11, 15, target is 9. So the first 2 numbers, 2 and 7, add up to 9, so we need to report 0 and 1. But the output is 1 and then 2. Why? Because the question specifies it's a 1-indexed array, so we need to add 1 to the indexes to 0 and 1 to make it 1 and 2. So that's the example. So how do we apply our 2 pointers method to this? Let's take a look at the solution. We will create the function, so definition, 2 sums, this is the name of the function, and then the numbers. This is what we are given, the list of numbers, and then the target. First of all, we're going to initialize our left pointer and right pointer. Our left pointer is going to be 0 because there's that 0 indexed, and then our right pointer is the last index. So the length of the number minus 1. Okay, then we're going to try to meet in the middle. using the while loop. While this left pointer is less than the right pointer, we're going to initialize a variable called the sum, because the question is asking us to add two numbers. Sum is equal to the left number plus the right number. So this is our window in the template. And then we're going to compare this window to our target that we're given, because we need to make sure that the two numbers from this numbers list is equal to target. So if this number that our sum is equal to this target, we're going to just return. This is going to be our answer, our left pointer and then right pointer directly. Because the question also specified that it's one indexed answer, so we need to add 1 to both the left pointer and then right pointer. What if our answer is less, our window is less than the target? It means that our answer is small, so we have to move our pointer to the right, our left pointer to the right. So we do that by left plus 1. So that's how we increase our sum. What if our sum is less than the target? We're going to do the opposite. We're going to move the right size to the left. So that we do that by right minus 1. So in this way, we're going to find our answer at some point. If nothing happens at the end, like we don't find anything, we're just going to return this null or an empty list. So that's when we don't find anything. So if you find something, it's going to be this answer. If we don't find anything, it's going to be that answer. Okay, let's just quickly review. So we initialize our pointers, and then we will try to meet at middle some point. We will calculate the window, and then we will compare our conditions. So if that's the target, we're going to return the answer. If it's going to be less than, we're going to move the left pointer. If it's bigger, we're going to move the right pointer to the left. If nothing is found, we're going to return a empty list. This is how we apply the two-pointers template to this problem. Let's just quickly copy this, submit this, and then see if it's going to work. So as you can see, it accepted our answer, and then we beat 97.64% of the answers. So it's quite successful. So this is how we apply the two-pointers pattern to our LeetCode question. So in our next video, we're going to solve more problems with this specific two-pointers pattern. Stay tuned. If you like this content, please subscribe and check out other similar videos.